Alright, hello and welcome to an introduction to trigonometry and trigonometric functions. So, let's just jump right in. Trigonometric functions are defined by a right triangle. So let's draw just a simple right triangle. If you're not exactly familiar, a right triangle is a triangle where one of the angles is 90 degrees. So in this case, it's this one right here. Also, with right triangles, just a quick convention, the side opposite the 90-degree angle is called the hypotenuse, and the other sides are called the legs, and we'll have other ways of naming them in just a second. So let's just call one of these angles of the right triangle, let's call that angle A. Could be any name, I'll just choose to call it A today. You could call it B tomorrow, call it C on Wednesday, or whatever you want to do. Anyway, so from the perspective of angle A, let's label this triangle in a more detailed fashion. So we already know that we can call this side the hypotenuse. I'll abbreviate that to just HYP, or hype, but hypotenuse. Now from the perspective of angle A, the opposite side is going to be this side. Okay, that's the side opposite angle A. I'll label that OPP for opposite. The last side, this last leg of the triangle, I'll call that ADJ, short for adjacent, because it's adjacent from the perspective of angle A. Okay? Now let's just suppose that we want to make a function, and we'll call it the sine function, why not, which relates the opposite side of an angle to the hypotenuse of a right triangle that uses that angle. So this is just an idea. We're just supposing that we have some function, we'll call it sin, short for sine, sine of our angle A, and we'll say that we define this as the ratio between the opposite side and the hypotenuse. Okay, it's just an idea. Maybe it can help us understand triangles in a different way and maybe do some different things with them that we weren't able to do before. So similarly, let's just suppose that we have a function called cosine. This we abbreviate COS, but we still pronounce it as cosine of A. Cosine of our angle is instead going to be the ratio between the adjacent side and the hypotenuse. So still just an idea. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse. Simple enough to remember. Let's make one more function, and we'll call this the tangent function. Okay? And this is abbreviated tan of A. And this is going to be the ratio between the opposite side and the adjacent side. Okay? These are just ideas. These are ideas for functions that we like to have, or we think we might like to have. But it turns out that they're they're very useful in like physics and stuff like that. And just math in general. The study of triangles, which is what trigonometry is. So remember these. These are the definitions of our trigonometric functions, sine, cosine, and tangent. Now, how could we use these? Let's pretend for a moment that we can calculate sine, cosine, and tangent of any angle. If you have an advanced calculator, or even some of the less advanced calculators have this functionality, you've seen a sine button and maybe a cosine button. Those are used to calculate sine and cosine of angles. But why would we want to do that? Well, let's look at a hypothetical situation. I'm going to draw just a nice right triangle here. Nothing too fancy. This is 90 degrees, and I'm going to tell you that the hypotenuse of this triangle is something like, let's make it 7. Okay, the hypotenuse is 7. And I tell you that the length of this angle, or sorry, the measure of this angle is maybe something like 35 degrees. Okay, and I ask you to find, well, I label the other legs of the triangle as X and Y. And I tell you to find X and Y. That's your objective here. All you know is that this is a right triangle, you know one of the angles, and you know the length of the hypotenuse. So how would you go about doing this? Well, let's label this triangle from the perspective of our angle 35 degrees in this case. Y is our opposite side, X is our adjacent side, and 7 is the hypotenuse. Alright? Now what do we know about relating the opposite sides, the adjacent sides, and the hypotenuse side? Well, we can use those trigonometry functions that we just kind of invented. So we know that sine of any angle, in this case 35 degrees, is going to be the opposite side over the hypotenuse. Now we're assuming that we can calculate sine of 35 degrees using a calculator. So if you look at this equation, how many unknowns do we have? We know this term. Do we know the hypotenuse? Well, sure, they gave it to us at 7. So we only have one unknown, and that's our opposite side. And we also know that y is our opposite side. So if we could solve for this unknown, we could figure out what y is pretty easily. So let's very simply multiply both sides by the hypotenuse. We get that hypotenuse times sine of 35 degrees is our opposite side. And we know that our opposite side is y. So from this we can say, let's just go ahead and simplify, y equals the hypotenuse, 7, times sine of 35 degrees. Alright, very simple. And we've used our trigonometry functions to find the length of another side. Now this doesn't really mean anything to someone who's not really familiar with sine and cosine or whatever. So if you want your answer in a more simplified form, you go to a calculator. I just have an online one right here. So we want to know what, let's see, 7 times the sine of 35 degrees. Make sure your calculator is set in degree mode, if you have the option, that is. And let's see what this is. Calculates it out as 4.015. So let's write that in. Y equals 4.015. Alright. Very good. Now all we need to do is find x, which is just as simple. So again, this time we know that cosine of 35 degrees is the adjacent side over the hypotenuse. We know everything in this equation except for the hypotenuse, except for the adjacent side. So we know that hypotenuse times cosine of 35 degrees is going to be our unknown, which is the adjacent side, which is the same as x. So we can just take 7 times cosine of 35 degrees to get our side x. Let's put this into our calculator. 7 times cosine of 35 degrees. And we get 5.734. Okay, so write this in green so it's consistent. X equals 5.74, I think? Yeah, 5.734. Make sure this is low enough. Okay? I don't want to scroll around that much. So, using our the knowledge that was given to us at the start of the problem and our trigonometry functions, we've been able to determine the lengths of the other sides of this triangle knowing only the hypotenuse and one of the angles. So just to finish off the problem, let's go ahead and just relabel the entire triangle using the information that we figured out. So we know that the opposite side is 4.015. Let's write that in. 4.015. And the adjacent side we found to be 5.734. Alright, so we found x and y just like they asked, and this is one possible triangle, well, the triangle that has a hypotenuse of 7 with an angle here of 35 degrees. So that's all I'm going to talk about today. Thank you for watching, and see you guys next time.